Now we're going to actually graph rational functions. To do that, we need to identify holes in vertical asymptotes and then create a t-chart or use our calculators to graph the function. If we choose, we can use the x and y intercepts as a starting point that will give us some good places to plot on our graph. So let's start with an example. F of x equals x over x plus 1. First of all, we want to make sure that this is completely factored. In this case, x over x plus 1 is completely factored, so we can go ahead and look for any holes or vertical asymptotes. Since there are no common factors, x and x plus 1 are not common factors, we can assume that there are no holes in this graph. So, no holes. Second thing we look for is vertical asymptotes. We see that the denominator, x plus 1, is going to go to 0 at some value of x. In that case, the value of x we're looking for is x equals negative 1. So that's going to be a vertical asymptote, the line x equals negative 1. When we start to graph it, let's go ahead to put that vertical asymptote right away on our graph as a guide for us. Next thing we need to do is either punch this into our calculator or create a t-chart of x and y values. I would recommend setting your x values around that critical point of x equals negative 1. So we put that in the middle and work on both sides of it. If you punch these values in your calculator, you will get values that look something like this. You'll notice that x equals negative 1 is going to be undefined, and that's because it's our vertical asymptote. Next, we actually need to plot these points on our graph, and it's going to come out looking something like this, where we have a line that's steadily moving upwards and then takes a steep turn up. On the other side, the same thing, coming very close to the vertical asymptote but never touching, and then slowly curving down until it hits a flat line. You'll notice that as it approaches this line on both sides, that line happens to be y equals 1, the horizontal line. That would be considered a horizontal asymptote. In this section, we're not going to focus too much on that, but it is something to be aware of. My only last reminder before we move on to the next example is that if you are using your calculator to graph this, make sure that you're using your parentheses properly before you type it in. In your numerator, now there's really not much going on up there, so these parentheses would not be necessary. But you have your x divided by a symbol, followed by parentheses around your entire denominator. Because if you do not do that, you're going to be actually graphing a different function. Let's try another example here. We want to graph this polynomial, or this rational expression, excuse me. So what we're going to do is factor the polynomial on top, factor the polynomial on the bottom, and see if there are any holes or vertical asymptotes. If we factor the numerator here, we can factor that down to x plus 1 and x plus 4 by simply unfoiling that. And our denominator is in its simplest form already, so we'll leave that at x plus 4. From this stage, once it's completely factored, we look for factors that are the same in the numerator and denominator. X plus 4 is going to be that factor in this case, and that's going to be our hole. So when we're looking for our holes, we're looking for something that is in common in both the numerator and denominator. So the hole will occur at the place where this goes to 0, or x equals negative 4. Then we need to simplify the function that's remaining. To do that, you simply cross out the common factors, and you're going to be left with f of x equals x plus 1. Now, x plus 1 doesn't even have a denominator, so there is not going to be any vertical asymptote for this problem. When we look at the function x plus 1, not too hard to graph. It's simply a line with slope 1 and y-intercept of 1. However, if we did want to make a t-chart, I would recommend working near your critical value, your hole of x equals negative 4. So let's do that, and let's plug in the y values. It's going to just simply be 1 more than x. And you'll notice here that we can actually calculate at the point of our hole a value of y. If we plug in -4 into this function, f of -4 is going to be simply -3. However, when we actually put it on our graph, when we plot all these points, you'll notice that we put an empty circle at that value of x because it is technically undefined by the original function here, where it has an x plus 4 in the denominator. On this last page here, this is not in your notes, by the way, just included a couple examples of things you might run into. You're not only going to have one vertical asymptote in every problem. So here's a couple examples where there are two. Notice that they don't always behave in the same way. In this case, the line is heading up towards positive infinity, coming from negative infinity, turns around, and then does the opposite behavior on the other side. Whereas here, it's coming from the top, going down, and coming from the top and going down again, coming from the middle and going down. So there are different behaviors you can expect, but there are many different functions that you'll come across when working with rational expressions.